Okay. Good evening, everyone. Okay, I can see a lot of you are there in the chat. So, hello, Karthik. Hello, Abhishek. Okay, Karthik has one question here. Key waiting for quiz. So, guys, we are having one quiz today. Okay, at 8:40, around 8:40. So there you will get a chance to get a free admission at our Java interview accelerator program that we are discussing from day one, right? So today we have that quiz. So apart from that, hi Dhruv, hi Yash, and yeah, Sam is there, Jeshwant is there, Sidhu, Amit is there, Sonu, Yugenda, Roshan. Hello everyone. Yeah. So guys, if you have any doubt till now about any control statement, please write in the chat. Okay. About the variables part, please write in the chat if you have any doubt till this point. Okay. So today, like we are left with the for loop. So we are taking one good problem statement and we will be seeing ki, hey, how I can like how we can build up problem solving skills, how to approach a particular problem, right, everyone? So the agenda of today's session will be about the problem solving session. Okay. And after that, at 8:40, we are having the quiz session, right? Okay, great. So let's start our session, right? 1 minute, guys. Let me share my screen. If you have any doubt apart from that, anything you have to ask, you have time, Ravi. You can ask, right? What about project, Karthik? We have discussed that number guessing game project yesterday itself, right? So what I thought is like yesterday we have that number guessing game project. So today let's take a problem solving session, okay? So that you get a proper view of uh, how to approach a project part, okay, simple project part, and how to approach a problem, okay, everyone. युगेंद्र is saying कि hey Java में internship कैसे मिलेगी? So Yugender, sorry. So what you have to do is like you have to make 2 to 3 good projects. Okay, that is learn the basics of Java. After that, move to the advanced part, that is the data structure and algorithm. After covering the data structure and algorithm, you can create a 2 to 3 project, that is learn Spring Boot framework. Okay, and create 2 to 3 good project. And after that, you are industry ready. Okay, internship ready, and you can give the internship interview and you can crack there, right? I hope together you are able to get the answer, right? So basically, Sidhu, it is like yesterday what we have discussed till now, we have made a simple project, right? So today we are going with the problem solving session, okay? And this session is very interesting. You will get to know a lot of things today, okay? So shall we start, guys? Let me share my screen, okay? Share screen. So everyone is having understanding of for loop. Please write in the chat. Okay. When will we get the certificate? After 9 p.m. Okay, when the session will get over, the link will be open for the certificate if you are eligible for the certificate, right? Saloni? So guys, my question here is ki we are left with the for loop. Can you guys write in the chat who all knows about for loop and who like anyone from the audience who don't have any idea about for loop, please write in the chat. Okay. Everyone knows what is eligibility criteria for the certificate, Vaishali? The eligibility criteria is like you should have like more than 50% of attendance. Okay, that will be the eligibility criteria, right? And you are submitting the attendance on time, right? It is not like you have submitted you have marked all the attendance in one day, right? Okay, Karthik is saying ki, hey, I know complete Java. So Karthik, let's take like I can see all of you know about for loop. So let's take a problem statement, right? So the problem statement is simple. What you have to do is you have to write a program to check, whether the number is a prime number or not, right? Whether number is prime number or not. And with the help of this question, we are going to learn why observation is important, why optimization is important, why time is important, right? When we are writing the code. So write a program to check whether the number is a prime number or not. So guys, those who know about Java, please write in the chat what is a prime number. Like this is a simple question, like the basic math question. Anyone from the audience, what is a prime number, guys? बोलेंगे हाँ sir, okay. Like chat GPT you can use, but yeah, like if in the interview they will ask you ki, hey, what is a prime number, then what you will say? A number that is divisible by 1 and itself. Okay, only 1 and itself as factor divided by 1 and number itself. Okay, so still I am searching for the correct answer. Okay, a whole number greater than 1 whose only factor are 1 itself. No, a prime number can be defined as it cannot be divided by any only in one end. Okay, still guys from the audience, still I am searching for the correct answer. No one. What is a prime number? If you know about core Java, if you know about Java, and yeah, if you have idea about prime number, then what is a prime number, guys? Okay, according to the audience, they are saying ki, hey, okay, Aman is correct here. A number which has only two factor. Okay, still Aman, you are not uh, fully correct. Like you are correct here. So guys, like most of you saying ki, hey, the number that is divisible by 1 and itself. Okay, can you guys write in the chat if you are saying ki, hey, the number that is divisible by 1 and itself, then what is 1? 1 is a prime number or not? Please write in the chat. Okay, according to your definition, 1 and itself is a prime number, the number that is divisible by 1 and itself. Then 1 is a prime number or not? Please write in the chat. Okay, no, Jeshwant, 1 is not a prime number, right? So the correct definition of prime number is what? A number that is having two unique factor. Okay, two unique factor, and that factor may be 1 and itself. Okay, but it should be having two unique factor. That number is a prime number, right everyone? Yes or no? Okay, so this is a correct definition of prime number. So what I got to know about this prime number ki hai, in order to check whether a number is a prime number or not, I have to calculate all the factors. Okay, from here I got to know ki, hey, if I have two unique factor, that number is a prime number. So I got an idea ki in order to solve this question, I have to calculate all the unique factor. Okay, sorry, not calculate, count all the unique factor, right? And here, if my factor, right, if the count of the factor is equal to 2, that is, if I am having two unique factor, that number is a prime number, right? Else that number is not a prime number, right everyone? So first we saw the definition of prime number, then we have concluded ki, hey, in order to check whether the number is a prime number or not, I have to calculate, I have to count all the unique factor, and after that I have to take a decision whether the count is equal to 2. I have to print the number is a prime number, else I have to print the number is not a prime number, right everyone? Okay, yes or no? So the now I got to know ki, hey, somehow I have to calculate this, count all the unique factor, right everyone? So let's take one number and let's try to understand that point. So 7, yes, 7 is a prime number because 1 is completely divisible by 7, right everyone? 1 is completely divisible by 7, so 1 is a factor of 7, right everyone? After that 2 is not completely divisible by 7, so 2 is not a factor of 7. 3 is not completely divisible by 7. Okay, 3 is not a factor of 7. 4 is not completely divisible by 7. 4 is not a factor of 7. 5, no. 6, no. Again, 7 is completely divisible by 7. So 7 is a factor of 7. So here the count of unique factors are what? It is 2 here, right? So 7 is a prime number, correct? Let's take one more example. Let's take the example of 4. 1, yes, 1 is completely divisible by 4. So 1 is a factor of 4. 2, 2 is completely divisible by 4. 2 is a factor of 4. 3, no, it is not completely divisible by 4. 3 is not a factor of 4. And similarly 4, yes, it is a factor of 4. Right everyone? So here you can see I have 3 unique factor. So this is not a prime number. So first we saw the definition. After that we concluded some point here, and after that what I need to find, I need to count all the unique factor. I take two example here, that is 7 and 4, and I observed one thing, that is I have to start from 1. I have to start from 1 and I have to go till n. I have to go till n. The value of n is 4 here, the value of n is 7 here. So the end point is what? N, right everyone? So I got the starting point, I got the end point, and at each step, at each step, at each iteration, you can say, yeah, at each iteration I have to check whether I is completely divisible by n or not, whether I is a factor of n or not, right everyone? So what I can do now, I can write like this ki, hey, let's take a number that is int n is equal to 5, right? Let's take this number, and after that what I will do, I know the start point, I know the end point, right? So here I will write a for loop, right? For loop, and inside the for loop here I will write int I is equal to 1, because this is the starting point. And how I came to know about the starting point? From the example itself, ki we are starting from 1, we are going till n, and at each value of I am checking whether I is divisible by n or not. If it is divisible by n, I am counting that I as a factor of n, right everyone? So here also what I will do, I will take int I is equal to 1, I is less than equal to n, and I plus plus, right everyone? Or you can write like this, that is I is equal to I plus 1 here, right everyone? And after that I will take one more variable count, and I will initialize count with 0. Okay, and here I will write a check ki, hey, if n modulo I is equal to 0, that is why I have written this line, in order to check whether I is completely divisible by n or not. And how I can check that point? If the remainder is 0, that means that number is completely divisible by n, and that means I is a factor of n. So here what I will do, I will increase the value of count, that is count is equal to count plus 1 here, right everyone? And after that, yeah, I am done with the part. And here, after moving out of the for loop, here I will write a check ki, hey, if count is equal to n, sorry, if count is equal to 2, here I will print system.out.println prime number, right? Else I will print ki, hey, system.out.println not a prime number, right everyone? Till this point, anyone has any doubt, please write in the chat. Okay, Aman? Yeah, like you're saying math dot square root n. Aman, why you are saying math dot square root n? Okay, please write in the chat. This approach will increase time complexity of a program. Utkarsh, how it will increase the time complexity of the program? Okay, till this point, everyone is clear how to calculate whether the number is a prime number or not. Please write in the chat, guys. Yes or no? Program is clear? Yes? No doubt. Okay. So let's try to see. Okay. So like those who know about time complexity, it is good. Those who are like new to this Java essential and those who are new to the programming world, okay, what is there is like we write a simple code and we have to optimize the code, right? And there is a very important part that is the time complexity and space complexity. Okay, everyone. So let's take one example and then you will get the clear understanding, right? Let's take a system. Okay, this is my computer and let's assume ki hey this system is doing uh, okay, let's assume this system is doing 1 minute, guys, let me see. Okay, yeah, so let's assume here we have the system, right? And in this system the processor is doing 10 to the power 8 iteration in 1 second, right? 10 to the power 8 iteration in 1 second, right, everyone? Everyone is clear what is this iteration? Iterations means how many times this body of the loop is getting executed. Iteration means again how many times the body of the loop is getting executed, and that loop can be your for loop, that can loop can be your while loop, and that loop can be your do while loop. Clear? Yes or no? So I have a system and that system is doing what? It is executing 10 to the power 8 iteration in 1 second. In 1 second, it is executing 10 to the power 8 iteration. Right, everyone? Yes or no? Okay. So tell me one thing. How many iteration this for loop will do? Please write in the chat. How many iteration this for loop will do? How many iteration this for loop will do, guys? Correct. 5 iteration, and Roshan is saying ki hey, n iteration, and n iteration. Correct. You are starting from 1, you are going till n, and each time you are incrementing the value of I by 1. Right, everyone? So that means this for loop will do n iteration, right? N iteration. That is the value of n is what? It can be anything. It can be 1, it can be 10, it can be 20. But we know one thing ki my for loop is starting from 1 and it is going till n, and each time I am incrementing the value of I by 1, right? So it will be equal to n iteration. That is the body of the for loop is executing how many times? It is executing n times, right, everyone? Okay, so let's remove this part now, right? This one, this one, and here we are saying ki hey an iteration it is doing, and we have a system. In that system we are running this code, and in that system the configuration is what? One iteration is taking 1 upon 10 to the power 8 second. Yes or no, guys? I can write like this ki hey I have a system, and in that system one iteration to execute one time the loop, it will take 1 divided by 10 to the power 8 second, right? So let's assume if I have to check the value of n is 10 to the power 9, if I have to check whether 10 to the power 9 is a prime number or not, okay, prime number or not, yeah, how many okay, how many seconds it will take? How many seconds? it will take to execute the whole code? Please write in the chat. Here I am saying ki, hey, in my system, one iteration is equal to 1 upon 10 to the power 8 second. This is the configuration I have. And I have to check whether 10 to the power 9 is a prime number or not. And for that thing, I have written this code. Okay. And inside this code, I have a for loop that is doing an iteration. So one iteration is equal to 1 upon 10 to the power 8 second. So 10 to the power 9 iteration will get executed in 10 to the power 9 upon 10 to the power 8 second. I can write like this, yes or no? Yes or no, guys? And this will be equal to 10 second, right? This will be equal to 10 second. So what I am getting from this result, ki, hey, this program is taking 10 seconds to check whether 10 to the power 9 is a prime number or not. Please write in the chat if it is clear till this point. Okay. Sir, please explain. Okay. Utkarsh, you will get a very good conclusion after that. Okay. Like after this problem statement, you will get a very good conclusion, right? Yeah. Okay. Those who are new, they are able to understand this part. Please write in the chat, guys. Okay. Then I will move to the next step. This 10 second is clear? Yes or no? Sidhu is saying yes. What about others? So tell me one thing, okay, if you are getting the idea, if everyone from the audience is getting the idea, if I have to check whether 10 to the power 18, okay, whether 10 to the power 18 is a prime number or not, right? Prime number or not, right? Can you guys write in the chat if I am using the same system, if I am writing the same code, if I am executing the same code, then how much time it will take to check whether 10 to the power 18 is a prime number or not? Please write in the chat. Okay. So those who are able to answer this part, they will get a free admission in the Java Accelerator program. Okay. You have only 1 minute. Okay. Try to answer that part. Yeah, it will be 10 to the power 10. Okay. I want the proper this. Abhindu, I want the proper time, right? Yeah. Roshan is saying 10 to the power 9, 10 to the power 10. Okay. Please repeat the question, yaar. Like, then what is like? They will, those who are able to get the question, they will answer first, right? So the question is, ki, hey, I have to check 10 to the power 18 is a prime number or not. So for that part, I'm using this system, and in this system, what I know, ki one iteration is taking 1 upon 10 to the power 8 second. So 10 to the power 18 iteration will take how much second? It will take 10 to the power 18 divided by 10 second. 10 to the power 18 divided by 10 to the power 8 second. That will be equal to 10 to the power 10 second. Right, everyone? Yes or no? Please write in the chat. Yes or no? So this 10 to the power 10 second is how much time? Anyone from the audience? This 10 to the power 10 second is how much time? It is like 1 day, 2 day, 1 week, 1 month. Anyone? Astafak is saying ki, hey, 10 to the power 18 is not the prime number. Astafak, you know, I know, but when I'm executing this code, okay, this code, then the computer will execute from 1 and it will go till n, right? And here the value of n is what? 10 to the power 18, right? Astafak? Yes or no? Sorry, Ashfaq, right? Ashfaq, yeah. It is 115.7 days. No, still I'm not getting the correct answer. So this 10 to the power 10 second is approximately equal to 317 years. Okay, this is approximately equal to 317 here. So what we have concluded, if I am writing this code and if I am using this machine, and in this machine if my processor is doing 10 to the power 8 iteration execution in 1 second, and if I have to check whether 10 to the power 18 is a prime number or not, then my computer will take 317 year to check whether that number is a prime number or not. Right, everyone? Yes or no? Okay, this we have concluded from this program and this mathematical explanation, right? Till this point it is clear. So what I realized, what I observed one point ki hey, like this is a very like huge time. Like we will like not there to check. Like my child, my grandchild will be not there to see whether this number is a prime number or not, right? If I will write this code and if I have to check whether 10 to the power 18 is a prime number or not, right? Yeah, it is clear, guys. Okay. So till this point, everyone is clear, right? So we are doing something wrong, right? Why it is taking too much time? Okay, guys, why this program is taking too much time? Anyone? So let's try to do reverse engineering from here, right? Let's try to do reverse engineering from here. Uh, this one. 1 minute, guys. Okay, let's remove this part now. And this one, right? So what we have observed, hey, I have a system, and in that system, 10 to the power 8 iteration is executed in 1 second, right? And in that system, yeah, so if I have to check 10 to the power 9 is a prime number or not, it is taking 10 seconds. If I have to check 10 to the power 18 is a prime number or not, it is taking 317 years. Right, everyone? Yes or no? Okay, so one thing is common here. You are saying ki, hey, it is taking a lot, like a very huge time, right? It is taking a very huge time. So one thing is there is like our time is dependent on number of iteration. That is, time is dependent on number of iteration, right? And this number of iteration is dependent on the loop, right? So we are doing something extra in the loop. That's why we are getting 317 here to check whether 10 to the power 18 is a prime number or not, right? What we have concluded, ki hey, 10 to the power 18 is a prime number, and it is taking is a prime number or not, it is taking 317 here to check this part, right? So my time is dependent on number of iteration, and that number of iteration is dependent on the loop part. So we are doing something extra in the loop, right? So let's try to optimize the code, right? Let's take one example here. So here in the example, this one, right? Yeah, this one, this one. Yeah, yeah. So let's take example of 24. Okay, 24 here. So in 24, just use break when the number is divisible and print the number is not prime, and use the n by 2, so it will take lesser. So world in one go is having one like observation here, and he's saying ki, hey, like Shubham is also saying the same thing. You can start the loop and you can go till n by 2. So Shubham, can you tell me, yeah, you both are correct here. That is, I can use a break here, right? The moment I am getting the count as 2, I can get a, like I can, here I can update this part, right? So Shubham is saying ki, hey, since this is a for loop and because of the loop, the number of iteration is increasing. So what you are saying ki, hey, if I will use a break here, that is count is equal to 2, I will break. There is no need to check for the remaining number, right? But this will not affect your time. Okay, let's assume you have to check this number. this like this. There is a number, and that this number is a prime number. Let's assume, okay, this number is approximately equal to 2, 4, 6, 8, 10, 12, right? So 10 to the power 12 plus 7, right? You have to check whether this number is a prime number or not, and let's assume this number is a prime number, right? Let's assume this number is a prime number. In this case, you will not go inside this part, right? You will not go inside this part because you will start from 1 and you will go till 10 to the power 12 plus 7, right? Right, Shubham? So it will not affect your time complexity when you have a very large number, right? Yes or no? So you are getting close to the answer, but it will not have a big effect when you have a very large number, right? And whenever you are writing the program, whenever you are writing the solution, that solution should be feasible, should be applicable for large number, right? Because let's assume you are working for Amazon and there is a client, like for the Amazon, so that Amazon client will focus on 10 million user, right? He will build us he will build a solution for 10 million user, and he will not build a solution for 100 user, right? Because he has to check a lot of things. Yes or not? Yes or no, Shubham? Yes. So here, here we have discussed कि here we have the time, and that time is dependent on number of iteration, and that number of iteration is dependent on the loop, right? So we are doing something extra in the loop part, right? So let's take a number 24. Okay, let's take a number 24 here. So let's try to check one thing. Okay, here, tell me one thing, guys. Okay, 1 minute. Yeah. So there is a number n. Let's assume 1 minute. Yeah. So there is a number n. Let's take the number as anything, 6. So tell me if you know that like this 6 will be made from a into b. If you know the value of a, 2, then you can easily calculate the value of b, right? That is, the value of b is 3. So if you know that a is a factor of 6, so you can easily calculate the next factor. Again, let's take one more example. Let's take 8, right? So let's we know ki hey, 2 is a factor of 8, right, everyone? So if I know 2 is a factor of 8, then I can easily calculate the next factor also, and that next factor is what? That will be equal to 4, right? Because you can write like this: 2 into b, and b is equal to 8 divided by 2, that is 4 here. So here I know one thing ki hey, this one, I know one thing ki hey, this formula n is equal to a into b. If you know one factor, you can easily calculate the next factor, easily calculate the next factor by this formula, right, everyone? By this formula. So this I came to know, right? And after that, let's take one example here. Let's take whether I have to check whether 24 is a prime number or not, right? 24 is a prime number or not, and I have written this code. So what will happen? So I know one thing ki hey, 1 is a factor of 24, right? When I am checking, the value of I is what? 1. So 1 is a factor of 24. So if I know one factor, then according to this formula, I can easily calculate the next factor also, right? That is, 24 will be the next factor, right? Similarly, when the value of I is 2, I know 2 is a factor of 24. So if 2 is a factor of 24, at that time, I also know that 12 is also a factor of 24 by this formula, right, everyone? If I know 3 is a factor of 24, yes, 3 is a factor of 24, right? 3 8 is a 24. So I can easily calculate the next factor, that is 8, right? 8 is a factor of 24 by this formula, right? Similarly, 4 is a factor of 24. I can calculate the next factor, that is 4 6 are 24, right everyone? Now I have 5. 5 is not a factor of 24. So if it is not a factor of 24, then this formula is not applicable. Okay, this formula is not applicable. So I will remove this part. After that, I have 6. For 6, 6 is a factor of 24, so I can easily calculate the next factor, that is 4. 8 is a factor of 24, so I can easily calculate the next factor, that is 3, right? And after that, I have what? I have 12, because 9, 10, 11 are not factor of 24, so this formula is not applicable, right? So 12, I will go to 12. 12 is a factor of 24, so I can easily calculate the next factor, that is 2. And similarly here, 24 is a factor of 24, and if I know 24 is a factor, I can easily calculate the next factor, that is 1. So this for loop is doing this part, right? It is starting from 1 and it is going till 24, right? It is starting from 1, it is going till 24, and it is calculating, it is counting all the factor. What I have done is, like, I observed one thing, ki, hey, if I know one factor, I can easily calculate the second factor. So the moment this line will get executed, that is n modulo I is equal to 0, at that moment, if this is true, if this condition is true, if this condition is true, guys, what we are doing, we are incrementing the value of count by 1, right everyone? We are incrementing the value of count by 1, but according to this formula, we can increment the value of count by 2, right? Because at a particular point, if I is a factor of n, then n by I is also a factor of n, right? If a is a factor of n, then n by a is also a factor of n. Yes or no? Please write in the chat if it is clear or not. Okay, guys, please write in the chat till this point, anyone has any doubt. So what I have done, again I am repeating that point, ki, hey, my time is increasing, and I came to know ki, hey, that time is dependent on number of iteration, and that number of iteration is dependent on the loop. So I am doing something extra in the loop. I observed one point ki, hey, I know this part, ki if a is a factor of n, I can easily calculate the next factor, that is b. Right everyone? This, that is, a is a factor, n by a is a factor, and if I am running this for loop from 1 till n, right? If I am running this for loop from 1 till n, then I know one thing ki, hey, at a particular point, if I is a factor of n, then n by I is also a factor, that is 1, 24, 2, 12, 3, 8, 4, 6, 6, 4, right everyone? So there is no need to do count plus 1. You can write count plus 2 here. Okay, count plus 2 here. This I got to know. Yes. Okay, so if it is clear, but it is not affecting the number of iteration, right? You are able to do this part, you are able to do this part, but if you will observe, it is not affecting the loop. You are not reducing the number of iteration, and the time complexity is directly proportional to number of iteration. So let's observe this table. Here we have the table, this one. Let's observe the table. Okay, can you guys tell me what extra thing, what repetition we are doing in this table? Okay, what repetition we are doing in this table? Anyone from the audience? What repetition I am doing in this table? Something is getting repeated, guys, in this table. Okay, yeah, like I'm getting to that point, Aman. Okay, anyone from the audience? Okay, so if you will carefully observe, after this point, okay, here after this point, we are repeating, right everyone? That is 124 to 12. That is, at this point my count will be equal to 2. At this point my count will be equal to 4. At this point my count will be equal to 6. At this point my count will be equal to 8. And what I need number of unique factor. right? I need number of unique factors, so I got 8 unique factor, right everyone? After this point my factors are repeating, and there is no need to do this part, right? There is no need to do this part, that is the below part. There is no need to do because we are repeating that part, right? So now I have to tell computer ki, hey computer, you have to stop at this particular line. Okay, you have to stop at this particular line. So how I will tell the computer? If you will observe, I have I and I have n by I. The moment the value of I is greater than n by I have to stop, right? So here you can see I have n by I. 1 is less than 24, 2 is less than 12, 3 is less than 8, and 4 is less than 6. But after that, the value of I is greater than n. That means I am doing the repeated task. Right, everyone? I am doing the repeated task. So I have to stop here. Right? So what I can tell the computer ki, hey computer, you have to use the for loop, right? You have to use the for loop till the time I is less than n by I. Right, everyone? Everyone is getting that point? Yes or no? Please write in the chat. Great. So I am telling the computer ki, hey, I have to stop at this point. That is I is less than n by I. So I can write like this ki, hey, I into I, that is I am taking the denominator and to the left hand side part, right? So it will be equal to I into I should be less than n. That will be equal to I less than square root of n, and that Aman is typing on the output on the chat ki, hey, you have to go till square root of n. Okay, so now you are getting the point. So those who have seen this solution somewhere, they will get the idea ki, hey, I have to go till square root of n. But this is a proper approach. You have to follow the proper approach in order to solve a good problem statement. Here we have a very basic problem statement, that's why you are able to answer this problem. But when you have a very good problem, then you have to observe everything. Okay, there is a why. There is a why. You have to ask, hey, why I am doing this part, right? Is there any way to optimize this part? Yes, there is a way. You have to make a table, you have to do some calculation, you have to observe some point, right? So I came to know ki, hey, there is no need to go till n. Why to go till n? Okay, why we are going till n? I am starting from 1 and I am going till n to calculate all the unique factor, right? But the moment I have made this table, I got to know ki, hey, I am getting the unique factor till this point. There is no need to go below it, right? So I concluded ki, hey, if you are going till I less than square root of n, you will get all the unique factor, and at the end of the day I want unique factor itself, right? So let's try to write the code again. 1 minute. So here I have the battery or not, let me see. Yeah, so okay, so let's write the code again. I will start from int count is equal to 0. Okay, let's take the value of int n is equal to something, 10 to the power 9 itself. Okay, and what I will do is like I will start from int I is equal to 1. Now I will go till I less than square root of n, right? And for this, what I can do, I can write like this ki, hey, math dot square root n. You can write like this, it will calculate the square root of n. Or the best way is to write like this, I into I should be less than n, right? I into I should be less than n. This is the best way. It will reduce the time complexity, right? It will reduce the time complexity, because if you are writing math dot square root n, then it is doing what? It is calculating the square root, right? It is calculating the square root, and this function is taking extra time, right? This function is taking extra time. Why to use this function when I can use a constant time here, right? Now when you are getting that point, you should use I into I should be less than n. You can use this part. Okay, it will like not harm the time complexity, but this is the proper way. Okay, after that, uh yeah, so let's remove this part, and you are saying ki, hey, I can write like this, I into I should be less than n, and I is equal to I plus 1, and here what I can do, if n modulo I, okay, if n modulo I is equal to 0, this is telling me ki hey, I is a factor of n. I is factor of n, and what we have concluded ki hey, if I is a factor of n, at that time I will get one more factor, that is n by I. So what I can do, if I is a factor, I can increase the value of count by 2, that is count is equal to count plus 2 here, right? This one, right? And after that I am done with the program, and here I will write if count is equal to 2, then this will be equal to prime number, right? Prime number, else it is not a prime number, right? Not prime number, right? So let's try to again run the code in my same system. Okay, again I have a system, the same system, and that system is doing 10 to the power 8 iteration execution in 1 second. Okay, that is in one iteration is executed in 1 upon 10 to the power 8 second. So if I have to check whether 10 to the power 9 is a prime number or not, okay, prime number or not, right? So here I know number of iteration are dependent on the for loop, and this time my for loop is doing how many iteration, guys? This for loop is doing how many iteration? It is doing square root of n iteration, right? Square root of n iteration. Yes or no? Please write in the chat. It is doing how many iteration? It is doing square root of n iteration here, right, everyone? So here, if I have to check 10 to the power 9 is a prime number or not, it is doing square root of n iteration, that is square root of 10 to the power 9 iteration, right? So one iteration is equal to 1 upon 10 to the power 8 second. So square root of 10 to the power 9 iteration is equal to square root of 10 to the power 9 upon 10 to the power 8 second. And here square root of 10 to the power 9 is equal to 10 to the power 9 divided by 2 upon 10 to the power 8 second. That will be equal to 10 to the power 4 point something. Let's take 4 upon 10 to the power 8 second. That will be equal to 0.00, okay, let's take 5 here, okay, 0.001 second, approx, right? So when you have written the previous program, okay, when you have written the previous program, there for 10 to the power 9 iteration, it is taking 10 seconds. So now you are able to optimize the code from 10 second to 0.001 second for 10 to the power 9 number, right? Like when I have to check whether 10 to the power 9 number is a prime number or not. Let's take one more observation. If I have to check 10 to the power 18 is a prime number or not, right? Prime number or not. In that scenario, again, my code is taking square root of n iteration. That means one iteration I know is equal to 1 upon 10 to the power 8 second. So here I have square root of n iteration, right? I have square root of n iteration, that is square root of 10 to the power 18 iteration. That will be equal to square root of 10 to the power 18 upon 10 to the power 8 second. That will be equal to 10 to the power 18 divided by 2 upon 10 to the power 8 second. That will be equal to 10 to the power 9 upon 10 to the power 8 second. That will be equal to 10 second. So the moment you have optimized the code, you have reduced the time complexity from 317 year to 10 second, right? To 10 second. And this is a power of optimization. This is a power of observation. So the agenda of today's session is about why optimization play a very important role to write a very good solution, why observation is important, right? And how you have to like approach a particular code, right? So this is a power, right, Aman? Yeah. So everyone is clear now? And you have to take a step, like you have to break the problem statement. When you are writing a particular code, you should know yes, what the question is demanding from me and how I am approaching that question, right? So the moment you have written the solution, think why, like after calculating the time complexity, you have to think, hey, why it is taking this much time? Is there any way to reduce the time? Okay, you will get the answer. If you will observe the pattern, you will get the answer ki yes, this is a way, and like this I can optimize the time complexity. And to observe this pattern itself, we have introduced a Java interview accelerator program, where we will teach you about all these things ki, hey, how we can approach a problem statement and how to solve any problem statement, like from anywhere, right? From the lead code, from the code step, from anywhere, right? Yeah. So everyone is clear? So again, so basically from here you can see ki, hey, and this is also true, like here I've taken a very simple example where I have taken a processor that is doing 10 to the power 8 iteration execution in 1 second, right? And this is a scenario, like you will get a different processor, there will be different cases, right? But one thing will be common, that is your time complexity will be dependent on number of iteration. Okay, this will be the very important factor, that is the time complexity is directly proportional to number of iteration. Okay, proportional to number of iteration. And why it is directly proportional to number of iteration, there are a lot of factors, I have to take a separate session for that thing. And yeah, like in future, if I have like if we are planning to take a session on time and space complexity, then I will tell you ki, hey, like why number of iteration, like why time complexity is dependent on number of iteration, because you have the stopwatch, you have the timer, built-in timer on Google. Why you are not taking that timer to check how much time it is taking to execute the code, right? Why you are taking number of iteration to check the time complexity? Okay, so there are a lot of things, so it is not possible for today, but yeah, you get the brief idea, right? So let me see, like about the program. So this is all for today's session, guys. And apart from this, those who want the certificate, let me share that part also, right? So here you can go to the description, and in the description here you can see the certificate option. After the session, you have to click on the certificates, and you will get the certificate part, right? You will get the option to generate a certificate, and from there you can generate the certificate, and there will be a quiz, right? Yeah, there will be a quiz. Let me see why like no one is there, right? Okay, 1 minute, guys, let me see. Okay, I think Prasad sir is joining right now, so he will take that quiz. 1 minute. So Boot, can you please ask Prasad sir to join? Yeah. Till that time, the quiz is all about the Java Interview Accelerator program that we are going to have from 1st May, okay, where we are discussing about the time complexity, the problem solving skills, how to approach a problem statement, all the data structure in detail. And this will be a very like good opportunity for all of you to take advantage. You can enroll in this course, because here you are getting placement, like this is a placement guarantee program. Yeah, and it will be like you are getting placed, it is all good. Like if you're not getting placed, then you will get the money refunded within 180 days, right? So here you can take the advantage, and you are learning a lot of new thing. Okay, because when you're choosing a path, you should choose a structured path, right? You will get the information from the YouTube and all, from the Google and all, but if you are getting the structured path, if you are getting the structured knowledge, if you are getting the uh, time to time analysis ki what you are doing wrong, then you will progress more fast as compared to other people, right? So you can take the advantage of this Java interview accelerator program. And here you can see the duration of the program, that is 3 months. What is the eligibility criteria? Anyone with which is having BTech degree or any degree, right? You can join this program. And here the fees of the program is 5,900 rupees, and this fees is also refundable if you are not getting placed. Okay, but like we are having like a good placement record, and here you can see who all got placed from our team. Okay, from our Let's Upgrade full stack Java, sorry, Let's Upgrade Java interview accelerator program, right? And most of you got a 10 LPA package here, right? So here you can see what all we are going to learn, that is OOPS concept, JDBC, SQL, DSA, IntelliJ, right? And yeah, Java, of course, here, right? And apart from that, here you can download the browser, and here we have interview, like sorry, our trainers who are going to teach you this program, right? So this is all for today's session, guys. uh, oh, so basically, guys, sorry, okay, what about quiz? Sorry guys, like I got the information from the team, and they are saying ki, hey, like we have very less attendance today, so that's why it is not possible to conduct the quiz. Okay. But in the next boot camp, that is going to be that will start from, I think, next Monday. Okay, from there you can join that session, and there we will be having the quiz part. Okay, so I'm getting the information from the team, so they are saying that part. But you got the idea, right? Information is important. You got the idea about the time complexity, the observation one, and the optimization one, right? Apart from that, you can join the next session, right? Okay, everyone, you can join the Karthik and all. You can join the next session that will start from Monday. Okay, and I am taking that session where we are going to discuss about the data structure, not in great detail, but yeah, I will tell you of each and everything that I know about array searching and sorting, where to apply searching and sorting, about linked list and all. Okay, in that bootcamp essential, that is the DSA bootcamp essential, you can join there, and there you have the quiz part. Okay, on the first day itself. For computer science student, it is like really mandatory to learn about any of database available like SQL, Oracle. Jeshwant, when you are you can say ki when you are doing the project, right? So here we are storing the data in a temporary variable, right? So when the program is getting executed, till that time we have the lifetime of the variable. The moment that the program is ended, the variable is not there, right? But we want the data, permanent data somewhere, right? To store that permanent data, we need the database, right? So it is important to learn the database. Like you should know the basic SQL queries, or like if you're using SQL, you should know the basic MongoDBs like queries, right? So you can learn that part. So database is important. Okay, Jashwant. Yeah. Like most popular is like SQL. You can go and learn about SQL part, and it will be good. Like anything else, guys, using Java? Yeah, yeah. Sonu, that essential, that is the DSA essential, will be using Java. Okay, we are going to learn about the data structure using Java itself. Okay, great. Thank you everyone for attending this session. Still, if you have any doubt, you can write in the chat. Okay. Apart from that, like hope you are able to get the clear understanding of what is the control statement, what is this variable, and this problem solving session. And yesterday we have discussed a very small project, that is number guessing game, right? SQL Bootcamp is available in this channel. Yeah, it is available. Okay, you can go to the playlist, and from there you can access those bootcamp. Anything else, guys? Try to make a project, Aman. Okay, it is like if you, those who want to learn about SQL, try to make a project, try to apply that queries in the real world project. Okay, then you will get the clear understanding. Try to practice each and everything, right? Yeah. Okay. So guys, thank you for attending this session. Okay, hope you are able to get the like good amount of knowledge today, and we will meet again in the next session, that is our DSA session, that is going to start from the next week. Okay, and there we will be having the quiz, right? So sorry for the quiz, like I also don't know about that part because it is less audience today, so that's why we are not able to conduct that quiz. But on that day we will conduct that quiz. Okay. Yeah. Thank you.
If you have liked this Essentials program, which is giving you a confidence that you can become a developer, this is just a starting. You can enjoy this learning for at least next 6 months and also become a full stack web developer or a full stack data science person and crack a job end of the day. If you are interested for that program, just go check out LetsUpgrade's full stack program right now from the website. What are the key features of LetsUpgrade's full stack program? 3 key features of LetsUpgrade full stack program. Number 1, you get to learn everything live by an expert coming in from an industry. So this expert is working as a day job, and sham ke time, evening time, this guy is going to teach you in your classes. This cohort is going to be of only 20 students at the max. So lots of focus is there on you to make you an industry ready developer, and you can get jobs in 150 plus partner companies that we have got, that LetsUpgrade has got, NPCI, Red Cross and various other companies. Now talking about the second feature, you get to build 15 plus projects. These 15 projects will help you get the confidence that you can be the top-notch developer at any company. Let it be the FANG companies or the MANG companies, or let it be any tier 2 or service-based or product-based companies. Third and the last feature, we have an amazing job board where on a day-to-day basis, we get 10 to 20 job descriptions, JDs, job applications being uploaded by companies directly. You can go ahead and check out those all jobs, apply, and we will go and get you prepared for that interview. So this is the 3 things, 3 big USPs of LetsUpgrade's full stack program. Go join right now. You can avail a 20% straight discount. The price of this program is 36,600, but you can get this program for 29,600 right now. Go check it out and let's meet in your batch launch, which is happening this Saturday. Bye bye, take care, have a nice day.